Programs rarely run in a straight line and stop. Program flow is all about getting your program to loop, make decisions, and handle unexpected events. The Q language has commands for controlling all manner of program flow. The simplest way to keep your program running is to use a loop command. QG, the QGoTo command, will always branch to a specific line in your program. Let's add one after the FL move. I'll select the empty cell below FL and click the button to bring up the command selection window. Most of the program flow commands are here under QProgram. So let's select QG, the QGoTo. It needs a parameter. In this case, we'll enter 1, the line number we want to branch to. Now we download and execute. What we have now is pretty much continuous motion. Very little time elapses between the end of one FL move and the beginning of the next. Another simple command is wait time, which makes your program pause for some period of time. Let's add a wait time command right after the FL move so the motor pauses between moves. I'll select line 4 and choose Insert Blank Lines Above. Let's bring up that command selection window again. Choose the QProgram tab. We can wait for an input, wait for a move, or wait time. I've chosen wait time. It needs a parameter, the number of seconds we should delay. In this case, I will enter 0.5 seconds, so we get a half-second delay between each move. Now we download and execute. This time we get a move, a brief delay, and another move over and over again. Let's say we wanted to interact with another device. Perhaps a PLC would send a signal when we should begin moving. We can use the wait input command for that. I have a push button on my switch box that will make input 3 go low when I press it. I'm going to insert a blank line on line 2, right after the VE command. That's where we'll wait for the command signal from the PLC. Once again, the command selection window, we choose the QProgram tab and wait input. Wait input is going to need a parameter. I'll click in the parameter field, and in this case we want input 3 to be low. Let's download and execute. This time, our program is waiting on line 2. It's waiting for the input 3 low condition to be met to satisfy the wait input command. When I press the button, the move occurs, the wait time, and then we loop back to the WI. We're waiting on the WI again because I let go of the button while the motor was moving. A quick note about labels. You may have noticed that when I added the QG1 command to the program, the QProgrammer software automatically replaced the line number I entered with a label. These labels make life much easier when inserting and deleting lines during the development of your program. However, you cannot create labels yourself. In fact, the best way to use labels is to allow the software to handle them for you. In other words, always use line numbers when entering QG and other program flow commands, and let the software automatically apply the label. Now let's try conditional branching. If input 2 is low, we'll execute a clockwise move. If input 2 is high, we'll do a counterclockwise move. That will give our Q program a little intelligence. First, we must test for the condition that will make us branch. I've inserted a TI instruction into my program to test for input 2 being low. Next, we have a QJ, that's a Q jump instruction, which will branch down here to label 1 on line 6 if the condition is true. What that will do is jump over the DI command that changes the direction of the move. Let's watch what happens. We'll download and execute. Now right now, input 2 is open. so we're executing moves in the clockwise direction. Now, when I close input 2, we change direction. Sometimes you need to repeat a sequence of commands a fixed number of times. For that, we'll create a repeat loop using QR, the qrepeat command. We'll also need to pick a register to do the counting. Let's use register 1. To loop 5 times, we'll need to load register 1 with the value 5 using the rx command. Let's do that first. We'll insert a line right before the FL move. And that's where we'll load register 1 with the value 5 using the rx command. 1 is the register, 5 is the value. Now we just need to instruct the program to repeat. So right after the wait time, we'll put a qrepeat. The qrepeat will use register 1 to do the counting, and it'll loop back to line 4. Let's try that. Two, 3, 4, 5. Very nice. What happens if we have a sequence of commands that we need to execute at several places in our program, the exact same sequence? For example, maybe we want output 2 to go low for 500 milliseconds after every move. We could place the necessary commands everywhere they are needed, but that will use up a bunch of program lines, and if we ever want to make a change, we'll have to make the change at every occurrence of those 3 lines. It is better programming practice to create a subroutine in another segment that contains the 3 lines and call it after every move. I'll put the SO, WT, and SO in segment 2. First, I click on the segment 2 tab. Then, on the first line, I'll add my SO command to make output 2 go low. To keep that output low for 500 milliseconds, I need a WT command with a parameter of 0.5 seconds. Finally, we need an SO 2H to return output 2 to its high state. That alone does not make segment 2 a subroutine. We need one more thing. We need a QC, QCall instruction, at the end of the segment that will instruct the drive to return control to whoever called this segment. Very simple. Now, back on segment 1, let's insert a line after the FL. There, we'll do another Q call, but this time we'll give it a segment number, 2. That'll make it branch to segment 2, flash the output, and return here. Now let's download the entire program and execute. Now notice how we're bouncing back and forth between segment 1 and 2, and you can see the output change state in the I/O status monitor. What about the unexpected? If your drive faults because the motor stalls, you'll probably want your program to take action. The onFault command can make your program automatically stop what it's doing and branch to a fault handling segment. Here's a simple example. We'll insert an OF3 command at the start of the program, right here on line 1 of segment 1. OF3 tells your program to branch to segment 3 if a fault occurs. Now in our case, the fault is going to be a motor stall. It'll be detected by the encoder, and I have configured my drive to fault on motor stalls. Now, what about segment 3? Well, just to demonstrate the concept, I'll put a wait time in here of 5 seconds. That way, we'll see visually on the screen that we branched to segment 3. After the 5 seconds has elapsed, we'll go on to line 2, which is a blank line, which means, you guessed it, the program will halt. Now we'll download the entire program to the drive and execute. My motor is currently turning slowly. Now watch what happens when I grab the shaft and stall it. We can see in the alarm status that we've experienced a stall, and here we are on the wait time in segment 3. What if I want an input signal to force my program to branch, no matter what it happens to be doing? That's a lot like OF, but we'll use OI on input. So on line 1, segment 1, we'll replace the OF with OI. Now, we'll need a parameter. In this case, I want to branch when input 5 goes low. Wait, what about the segment number? Well, on an OI, you don't get to specify the segment number. It's automatically segment 10. So, let's go to segment 10, and we'll put a WT there with a 5-second delay, just so we can see what happens. Now I'll download my entire program to the drive and execute. So here we are running away on the FL. Watch what happens when I take input 5 low. There it is. We branch to segment 10. We'll wait 5 seconds and then the program will reach the blank line and terminate.